Welcome to our multi-part series on designing the ultimate smart home. We talked about structure of the home and electrical systems as well as HVAC. In this video, we're going to be diving into water systems, how to make them smart. My name is Steve, and this is it-alchemy. First things first, we're going to need water. Since this property is just outside city limits, municipal water sewage connections aren't available. That's not a problem. Private wells are common in Alaska. Some areas have a water table as shallow as 5 feet below the surface, but it's usually unsafe to drink and can disappear quickly during dry stretches. For a more reliable source, wells here need to be at least 40 feet deep, typically even 100 feet or more. To drill a well, we're going to need to bring in a drilling rig and drill down until we have a sufficient flow. Usually about 7 to 10 gallons per minute, but for a house of this size, it's going to be more like 15. Steel or PVC casing goes down into the hole, and it's reinforced with cement or bentonite grout to prevent leaks and contamination. Because we have really cold weather up here, the discharge pipe needs to connect to a pitless adapter. This lets the water flow underground below the frost line and back into the house. Combined with insulation and heat trace, freezing shouldn't be a problem. The pump itself is submersible, sending water up into the house. It first enters a pressure tank, which is a small tank with a bladder inside that keeps water pressure steady. Without this, the well pump would run constantly and burn out quickly. Now, deep groundwater is often pretty clean, but it's not perfect. Minerals, bacteria, chemicals, and organic matter can cause stains, taste issues, or health risks. Here's how we'll treat it. First, the water flows into a sediment filter, removing sand and dirt. This model is from Clack, and it has an auto backwash feature that cleans itself and flushes the debris down the drain. Next, and also from Clack, we have an FOB filter that removes iron and sulfur. It passes the water through an air pocket, oxidizing and trapping these unwanted elements, and the auto backwash feature keeps it clean automatically. Hard water minerals like calcium and magnesium are removed by a Clack water softener. Resin beads trap the materials, and periodic brine regeneration flushes them out to the drain. Finally, we have a disinfection system using ultraviolet light. Water passes through a 5-micron filter and then a charcoal filter to remove any remaining debris or chemicals before UV light kills bacteria and parasites. The treated water then goes into a cold water manifold and it's distributed out to the fixtures in the house. Hot water is generated by a Rheem hybrid water heater, which works like a heat pump but using ambient air. Electric elements handle peak demand. Secondary hot water comes from the geothermal system. The waste heat produced from the compressor preheats the water and it enters the main heater. Hot water is distributed via manifolds just like the cold water. Now this does seem like a lot of equipment, but this all really fits neatly into the corner of a garage. All of the water goes into the septic system. Gray water from the sinks and showers, black water from the toilets, and discharge from the water treatment and geothermal condensate all end up in the septic tank. If this is properly sized, it'll handle all of the wastewater efficiently. Now that we have water being distributed, there's some considerations for our fixtures. For example, some things don't need softened water, such as outdoor hose bibs or irrigation out to the garden, so we'll bypass the water softener to protect our plants. Speaking of hose bibs, I really like the Aqua V2 house hydrants. They maintain a flush drain that automatically prevents freezing. Since softened water has a slightly higher sodium content, we'll put a reverse osmosis filter in the kitchen so that this will purify water going to the sink or the refrigerator or the ice maker. And since this is a pretty large house, we'll want to put sub-manifolds and dedicated hot water recirculation lines in order to keep the hot water instantly available. Sometimes I shower with the wife, so in the master bath there's 2 shower heads. Now she likes the water a little bit cooler and I like the water a little bit warmer, so this will be controlled by a Moen smart shower system. This device has a digital thermostatic valve that can control and maintain temperature of up to 2 outputs independently. Lastly, we have access panels. Since we'll be using a smart wall system that was mentioned in our structure video here, our plumbing is run inside of the walls. Junction and service lines in some fixtures may need to be accessed from time to time, so having a sealed access panel in convenient locations can be a lifesaver, particularly with showers and bathtubs. Now, I love data. Even more, I love not having to manually check on things. To make the system really smart, we're going to add a stupid amount of sensors. We'll have leak detectors at every point of use, your sinks, your dishwashers, your freezers, your toilets, everywhere there may end up being a problem. There'll be flow rate monitors at key points like the well and 2 in each sub-manifold. This lets us track down the usage down to the location, such as the bathroom or laundry. This seems a bit excessive, I know, but wells are not unlimited, and I've come across more than one load of laundry that consisted of only 1 or 2 items, so I'd like to know how much water is being used and where. There'll be temperature sensors at the geothermal loop inputs and the outputs to ensure proper geothermal efficiency, as well as a salt sensor for the water softener. This is more of a laziness feature, just for me. The modern efficient water softeners don't use very much salt, but I am likely to forget to check and refill it. There'll be valve actuators to remotely turn off the water lines. This can really be a huge help if the water to certain areas need to be turned off quickly and you're not close by. Or if your pipes freeze up or have a spontaneous leak, you can shut them off remotely. Now, having this data can be extremely useful for monitoring your water pressure flow and even have some detailed usage about how it's being utilized within the home. This can be really useful for tracking down potentially costly leaks. With all of this in our ultimate smart home, we have a reliable, safe, efficient water system. With proper care and maintenance, we have a virtually unlimited supply of free water. How do you manage your water system? Leave a comment below and let me know. Also, remember to like and subscribe to this video. Stay tuned for our next video where we're talking about security systems. Thanks for watching.